All right, so today's lesson is test for parallelograms. So we're going to use the test for parallelograms to determine whether quadrilaterals are parallelograms. So parallelogram is just a shape that has two parallel sides to one another. So let's look at what those tests are. So if a quadrilateral has each pair of opposite sides parallel, it's a parallelogram by definition. This is not the only test, so that's one of the ways. So the other one would be Theorem 7.9. If both pairs of opposite sides of quadrilaterals are congruent, then the quadrilateral is a parallelogram. If both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Theorem 7.11 says if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. And 7.12 says if one pair of opposite sides of a quadrilateral is both parallel and congruent, then the quadrilateral is a parallelogram. So I know that's a lot, so we'll break it down as you go through this. So identify parallelograms. So determine whether the quadrilateral is a parallelogram. Justify your answer. So is this quadrilateral a parallelogram? Let's go back and look. So we know up at this top, it says if a quadrilateral has a pair of opposite sides parallel, then it is. But there's also other things. So if I look, so these two are parallel, the 5 and 5, because they'll never cross, and the 12 and 12 are parallel, because if they continue on, they'll never cross as well. But if we also look, if both pairs are congruent, then it is a parallelogram. So these are congruent, and these are congruent. So we could stop there because it is a parallelogram. So what theorem did you use to justify your answer? So we could say we use Theorem 7.9. 7.9 because the pairs of opposite lines are congruent. Let's try another one. So now use parallelograms to find values. So the top of the eraser appears to be a parallelogram. Find the values of x and y so that the side of the eraser is a parallelogram. So we know that, let's go find the theorem about angles. So if we look here, Theorem 7.10 says if both pairs of opposite angles of a quadrilateral are congruent, then it's a parallelogram. So we need to look at opposite. So we have to look here. Opposite of that is this. So let's solve for the first one. So my first equation will be 4y plus 4 equals 5y minus 26. So the first thing I will do, I'm going to get rid of this subtraction. I'm going to add 26 to both sides. So now I have 4y equals 4y plus 4 plus 26 is 30 equals 5y. Then I'm going to subtract the 4y from both sides. And now I get 30 equals y, because 5 minus 4 is that. So now if I plug it in, I'm going to do 4 times 30 plus 4. So 4 times 30 is 120, plus 4 is 124. And then if I do the other side, 5 times 30 minus 26. So 5 times 30 is 150. So we'll pull up the calculator so you can see. So 150 minus 26 gives me 124. So those angles are equal to each other. So now let's try the other one. So now these ones are diagonal from each other. So I have 56 equals 7x. So I can divide both sides by 7. So 56 divided by 7 is 8. So now I'm going to plug that in. 7 times 8 gives me 56. So those are congruent. So the theorem down here that we would use when we found it is 7.10. So we used theorem 7.10 because it states that opposite angles will be congruent. Okay? The next one, so this one says a parallelogram. A quadrilateral needs to pass only one of the 5 tests to be proven that it's a parallelogram. So if it meets one of these, it means that it's a parallelogram. So all of the properties of a parallelogram do not need to be proven. So we just did all of this right up top. All right, so let's try this one. So it says the mosaic pattern of how a floor is made up of different tiles. So find the values of X and Y so that the tile is a parallelogram. So I think it's easier, especially when you look at an image like this, to go figure out what theorem would prove it. So looking at this, I know that it's not angles because there's no degree sign after it. So if I look, it's talking about sides. So we have this one. So if both pairs of opposite sides of a quadrilateral are congruent, it's a parallelogram. So let's go look. So this one would fall for this side. This one is opposite of it. So we can solve for that then. So we know 3x plus 4 equals 5x minus 2. So the first thing I'm going to do is add 2 to both sides. So now I have 3x plus 6 equals 5x because that 2 cancels. Then I'm going to subtract 3 from both sides. So then subtract over here. So now I have 6 equals 5 minus 3 is 2. And then I'm going to divide by 2. So 6 divided by 2 gives me 3. So x is 3. Then I'm going to do the y. So let's see, make sure that those are. So this one would fall here. And then this one would be opposite of it. So I have 2y plus 5 equals 4y minus 9. So the first thing I'm going to do is add 9 to both sides. So now I have 2y plus 14 equals 4y because my 9's cancel. And then I'm going to subtract 2 from both sides. And I get 14 equals 4 minus 2 is 2. And then I'm going to divide. So 14 divided by 2 is 7. So then I plug that in. And then I use, so let's read. So what theorem did I use? I didn't use the angles, and I didn't use the bisect. So it's between this. So if both pairs of the opposite sides are equal, congruent, then it's a parallelogram. And if one pair of them is equal, then it is. So both of them were equal to each other. So my answer would be A. Put check mark over top of A for next. All right, so that's it for this lesson. I want you to now go create a lesson on how you would teach that to your peers.